All right, good morning, everybody. Happy Friday. We've made it to the end of this week. It's so good to have you guys here. I see we've got some students coming in. Welcome, welcome, everybody. It's always a pleasure having you guys and just being able to share some content with you and hear your answers and engage with you. All right. Just to remind you who I am Karabo Fiona Khashani. I go by KB_Khashani on Instagram and Karabo Fiona Khashani on Facebook. Please do follow us on STEM Lockdown Digital School. You'll find us on Facebook, Instagram, and all the videos have been uploaded on YouTube. So if there's anything that you missed, please do go on YouTube. Just search Africa Teen Geeks and all the videos will come up. On Facebook for all our announcements are also Africa Teen Geeks. All right, so basically, if you guys remember, yesterday we did not actually finish our slides. So I'm going to literally just fly through what we did yesterday. Just to remind you, we spoke about homework that you guys got, and I received some work from Mahumo. And Vutali, we spoke about conductors, about what makes a good conductor and what makes good insulators. Now, do any of you still remember what are examples of conductors? Or can any of you please give me an example of conductors and also an example of insulators? So in your Q&A, just write conductor and give me the list, and write insulator and give me the list. Just a quick recap from yesterday. I'll just have a look at your Q&A just to see if there's anything. Just a quick recap, just remind me, what is a conductor, what is an insulator, and just give me a couple examples of those items. Just as I wait for your answers. Right. All right, I see Anonymous says a conductor is gold. JD's giving me copper. That's a very good conductor, very good. Anything else that we have? What about a couple insulators? All right, Anonymous, an insulator is plastic. Very, very good. So a lot of you still do remember the differences between a conductor and an insulator. All right, so we mentioned that there are mostly metals are good conductors of electricity. We've got copper, which is actually the most common material. There is silver. Silver is the best conductor, but it's just very, very expensive. Gold is also a good conductor. It doesn't rust, but it's also very, very expensive. And there's aluminium. It's not as good as all the others, but it is still a conductor. And it is used where the weight is considered, especially because aluminium is not as heavy as copper. So all of these four are actually very good conductors of electricity. Right, then we also moved on to insulators. Now with insulators, these are materials that do not conduct electricity. There's 5 pictures at the bottom. We've got rubber, glass, oil, diamond, and dry wood. Now, specifically, it says dry wood. Now, if it was wet, all right, that would obviously cause a reaction if there was lightning. I remember somebody asked us, I think it was, I forgot who asked yesterday, but they asked, why is it that a tree can get struck by lightning if the bark is wood? All right, so most of the time, if a tree, if the wood or the bark of the tree is actually a bit moist, it acts as a very good conductor for electricity, and as it goes through to the ground and the electric current. All right. Now, we just mentioned that insulators do not conduct electricity. Plastic, rubber, this could be a blanket, all right? So lots of items that you think cannot conduct electricity are called insulators, all right? Very, very different from conductors.
Teacher, right. I just want you to note that when you look at the questions, your full screen actually becomes the question screen. It moves off of the slides. I don't know if that is intentional.
Oh, has it always done that?
No, it's only this morning that it's doing that.
Oh no! Oh dear. Okay, okay. I'll just have a look at the questions later on then. I actually had no idea. I thought it doesn't show at all. All right. Thank you. All right, cool. Let's move on. All right, now the importance of electrical insulators. So we spoke about why is it that most electrical appliances are covered in plastic. So just do answer me, and I will just look at your questions right at the end as to why is it that wires and kettle wires are covered in plastic. You find that, you know, with your cords, especially your kettle cord, your heater cord, your lamp cord, all of those are covered in plastic. All right. And obviously just helps to prevent us from getting a shock. Now, remember, I am just going through what we went through yesterday. If you were not in yesterday's lesson, you're more than welcome. Just go onto YouTube and catch that lesson, because I am just trying to get us through the content for today. All right. We also spoke about the do's and don'ts of ways to avoid getting an electric shock. All right. Now, there are 4 do's and 4 don'ts just to protect yourself from dealing with electricity. Obviously, the first thing is you need to seal all the unused electrical outlets. You need to throw away or repair items that have damaged cords. So if you are charging your phone or your laptop with a cord that is naked, where you can see the wire, that is not safe at all. You should actually get rid of that, throw it away or repair it. Remember, you always need to unplug any electrical appliances before you are repairing it. So you cannot repair the stove if it is still plugged in the main socket. You need to remove it from the main socket. And also only plug in one appliance at a time. So don't overload an electrical socket. You might find that many homes have plugged in a TV, a heater, a stove, this and that is actually very much, it's overloading and pulling too much power. So you're just encouraged to plug in one appliance at a time. All right, then what you should not do at all is to never pull a plug with its cord. Never touch electrical appliances with wet hands, and do not put your finger or any metallic object in the electrical outlets. And also, never use electrical appliances close to the water. And that's what some of you said yesterday, is that that's why you will actually not find any plugs or electrical sockets in the bathroom, because that's where a lot of water is being utilized. All right, and this is exactly where we stopped yesterday. All right, we actually stopped towards the end, and I was asking you, what is a conductor and what is an insulator? All right, and we said that a rubber band is an insulator, meaning it cannot conduct electricity, so electric current cannot pass through. A cardboard is considered to be an insulator. Coins, this could be a 5 Rand coin, 2 Rand coin, 50-cent coins. All right, those are considered to be conductors. A piece of wood is an insulator, right, depending on where it's placed. If it's still a live tree in the ground, all right, it's considered to be a conductor. But if it's a dead piece of wood that we would use to make fires or a nice braai, it would be an insulator. Then the last one is aluminium foil, which is a conductor. Aluminium foil is a conductor. All right, I'll give you just a couple seconds just to copy that down, just to know which material is what. Just to give you more examples in terms of a conductor or an insulator. So just for those who actually are copying down, I've got notebooks with you. That's some useful information. All right. So here's a little example, or rather just an activity that I would like you to do, and I will look at the answers at the end because I don't want to just disturb the two screens. Now it says electricians are people whose job is to work with electricity and fix the wiring in houses and other buildings. Electricians often wear rubber gloves. Why do they wear rubber gloves? So why do electricians wear rubber gloves? Please answer that in your Q&A, and I will have a look at your answers just about 5 or 10 minutes before the lesson ends. Why do they wear rubber gloves? So I'll give you a couple more seconds if you want to just copy down that answer or quickly write down your answer. All right. The next question is, what is the difference between an electrical conductor and an insulator? Remember, just get that in your Q&A and I will address it at the end. What is the difference between an electrical conductor and an insulator? All right. Now, I want you to tell me, why does the owl not get an electric shock from the power lines? I'm sure many of you have seen birds on power lines, but they don't seem to get electrocuted. Why is that so? So you've got 3 questions to answer for me. Why do electricians wear rubber gloves? What is the difference between an electrical conductor and an insulator? And why does the owl not get an electric shock from the power lines? I'm going to give you some time to write down those questions and to write down the answers. And please type it in your Q&A. I will have a look at the Q&A right at the end of the lesson. In fact, when I think about power lines, when I often go visit my mother in Limpopo, there are a lot of monkeys in the area. And in fact, all of those monkeys actually swing on the power lines, or they'll walk right across them, you know, to go to the next house or to go into the trees. And it's actually amazing as to why they don't get electrocuted. So if you look at that owl or even monkeys or even birds that are on power lines, why do they not get an electric shock? I am really looking forward to seeing your answers at the end. Right, I'm going to give you just 30 more seconds and we're moving on. Alrighty. Now, we know that electric circuits are used all around us. For example, in the lights in our homes, the streets, and the shops. Now, I want you to imagine our world today without electricity. So just take a few seconds and just imagine the world without electricity. And I want you to tell me, the third bullet point, to describe the 3 things that will be the biggest disaster for you if there was no electricity. What would be the biggest disaster for you? So what would possibly go wrong if you had no electricity? I'll give you my 3 things. Biggest disaster would be my phone. I wouldn't be able to charge my phone, meaning I cannot communicate with my friends and family because the battery would always be flat. The second thing would be, let me think. I don't like being in the dark, so I really need the lights to be on. I could probably use a candle, but a very big disaster would be being in the dark all the time. I really don't like being in the dark, so that's a very disaster for me. And the third disaster would be having to go to the shops to buy food and cook it right away, especially meat, because I wouldn't have a fridge with no electricity, meaning that I'd have to be cooking each and every single day. So that's my biggest disaster, my phone, sitting in the dark, and food. All right, so tell me what would be your biggest disaster if there was no electricity? I hope you're writing this all down and typing the answers in your Q&A as we move along. Sorry about that, guys. All right, so remember, just tell me your biggest disaster. Right. Next one, now systems to solve problems. All right, now how can we use electric circuits to make useful devices and appliances? Now we're talking about systems. All right, now systems to solve problems. And we're going to move into that deeper just for a bigger understanding. The next one says, what happens to energy when we use electric devices and appliances? Now you don't need to answer these questions. This is just what you need to know by the end of this lesson. All right. Electric circuits are often used to solve a problem where we need energy. A battery or mains supply is a source of energy. The energy is transported to a device or an appliance using electric wires. The device or appliance disperses the energy. The effect could be light, sound, heat, or movement. In other words, the device gives off energy in the form of light, sound, heat, or movement. Now we are talking about systems to solve problems. Let me give you an example. Let's think of a heater. A heater is a sort of machine, and obviously it solves a problem. What problem does a heater solve? What problem does a kettle solve? What problem does a stove solve? Now remember, we're talking about systems to solve problems, because something like a heater is a machine with many systems in place to make it work. But as soon as it works, what is their effect? What type of energy is being given off from the heater? Why would we say a kettle is a system? What problem is a kettle solving? All right. Let's have a look at that. That's a kettle, and I want you to tell me, what problem is that kettle solving? So in your Q&A, please just write kettle with a dash and tell me, what problem is it solving? All right, next picture. That is a heater. What system is the heater solving? All right. The next is a lamp. Remember just to write heater dash what it's solving, the heater a dash what it's solving, and the lamp. Now, what problem is the lamp solving? What about the speaker? What problem is that solving? Obviously, there's a problem. Now, what problem is a speaker solving? Couple more to go. That over there is a street light. What problem is a street light solving? Now, all of these pictures that you see on your screen right now are systems that are in place and that give off different energy. Some of them give off heat, some of them give off light, some of them give off sound. All right, so what system are they solving? So firstly, I would say that a kettle, what problem is it solving? It is solving us to obviously be able to get hot water to make tea or to cook. You know, without a kettle, we'd need to either maybe boil a pot on the stove, or we'd either need to make a fire. So instead of all of that, we just switch it on and the water starts to boil. The lamp is sorting a problem of light. All right, it produces light. That's the energy that it gives off. The speaker provides us with sound. If you want to listen to the radio or listen to some music, it's solving the problem of supplying us with sound. Street lights also very similar to the lamp. It is solving the problem of supplying us with light. All right, so light on the streets, obviously to help the cars that are driving and just to generally light up the street. All right, and we've got a fan. A fan is a system. What problem is a fan solving? All right, perfect. And the very last one is a robot. What system, or rather, what problem is a robot solving? So you've got 7 different pictures and they all give off different types of energy. But what system is a robot solving? All right, remember, just have that in your Q&A, and I am going to have a look at that right towards the end. All right, now let's get the meaning of systems. Please do write it down. A system is something that consists of different parts working together to form a whole. So if you think of a kettle, there are many systems and there are many parts in the kettle that make it work the way it is. Right. In an electric system, there is an input, which is the energy, and an output, resulting in either light, heat, movement, or sound. Okay, so the input would be me plugging it into the socket, and the output would be the result. Either if I plug in a lamp into the socket, the result will be light. If I plug in the heater into the socket, the result would be heat. And going on to either kettles, stove, microwave, radio. As soon as it's plugged in, it's obviously energy going in and an output, which is coming out. Light, heat, movement, or sound. Just a couple seconds to copy that down, just to understand what systems are. All right. All right, now let's discuss an engineer or a technician. What would you like to be when you grow up? Obviously, you don't need to choose from either an engineer or a technician, but you know, what is it that you aspire to be when you're older? And maybe some of you actually want to be engineers or technicians. So just in your Q&A, what would you like to be when you grow up? All right. Now, let's just say that you want to become an electrical engineer or an electrician. One of these things that you will be doing is to design systems that use circuits to solve problems for people, whether it is wiring a house, an alarm bell, a lighthouse on the coast, or constructing toys which use electrical energy to work. Now, that would be a job of a technician or an electrician, to obviously put wiring and just to make sure that things are working the way they're supposed to be. Electric circuits solve problems like getting electric lighting, for example. Now, we started off this topic by drawing electric circuits, light bulbs, batteries, switches. Now, those electric circuits are actually ways to solve problems. For as long as you've got your wiring correctly and you've placed the light bulbs and all other components where you need to place them, it is going to solve a problem. Now, there are many instances in the world around us where electric circuits are used. Now, electric circuits are used street lights, alarms, electric gates, traffic lights, fans, heaters, some models, and toys. Now, there are many other examples of where electric circuits are actually being used. All right, right now, the laptop is on. That is an electric circuit that has actually been happening. I've plugged it into my socket. It's charging at the same time. My phone is also some sort of an electric circuit, right? Because there are so many components that make it work the way it is. You know, some of you obviously got PlayStations and all sorts of stuff. All of those need to be connected properly in order for them to work the way they do. All right. All right, let's just have a look at this over here. Now, takeaway message. Now, some materials allow electric current in them. So if materials allow electric flow, they are called conductors. Now, materials that do not allow electric current are called insulators. So it's basically just the opposite. Materials that allow electric flow are conductors. Those that do not allow electric flow are called insulators. I'll give you just some time to copy down those notes. It is pretty bulky. There's still a lot more coming. All right, metals are usually conductors and non-metals are usually insulators. So most metals are usually conductors and non-metals are usually insulators. Electrical insulators have important functions like insulating wires or protection from electrical shock. An example, an electrician's rubber gloves. So previously I asked you, why do electricians wear rubber gloves? And I am going to have a look at that shortly. Now, electricity will always take the shortest path to the ground. Your body is made up of 60% water, and that makes you a good conductor of electricity. For this reason, wearing rubber gloves or rubber-soled shoes will protect you from mains electrical shock, but not from being struck by lightning. That is why it is encouraged when it's raining with heavy storms and lightning to constantly just be indoors and not to be outside, because you are a very good conductor. Yesterday I gave an example of my mother's stove and how nobody can cook on that stove if they are barefooted. They have to wear shoes, because if you don't wear shoes while cooking on that stove, you are going to get an electric shock. All right, so as soon as you touch the pot that is on the stove, you actually feel the current in your body. So we always need to wear shoes when cooking on my mother's stove. All right, so basically, wearing rubber shoes will not necessarily protect you from getting an electric shock from lightning. All right, now here's the answer that somebody asked yesterday about a tree. Now, if a tree has fallen on a power line and you touch the tree, you will become the path or the conductor to the ground and can be electrocuted. Trees are also good conductors of electricity, especially live trees. All right, and obviously that is why you never are to stand underneath a tree when the lightning strikes. All right, I'm just going to give you a couple more seconds just to note everything down, which will help you for activities that we are going to start doing from next week and so forth. All right, just a couple more seconds just to jot down and have a quick read and write down the important notes. Remember, you can't write everything. You're going to have to just write bullet points just to make it easier for you to understand. So call it note taking. All right. All right, now here's some very helpful links for you. You can find on YouTube, basically the differences between conductors and insulators. All right, just ignore that slide. All right, remember just to follow us on social media, and for more information, just contact me on Garabo at africanteamgeek.onmicrosoft.com. Now we're going to use the rest of this time just so that I can have a look at your answers, which I couldn't do during the lesson for some reason. So let me have a look at what we have over here. All right, so I see, sure, we've got a lot of information here that we need to get through. All right, so we've got Shakira that says, oops, I missed it. All right, I'll start over here. All right, we've got Buntle saying a heater obviously supplies heat. Very good. Caleb says the same thing. So does Queen. Very good. Anonymous. Oops, I missed Anonymous. It keeps going up. All right. Right, Anonymous says to study and other stuff. We got Shakira that says we would get bored because most of our entertainment needs electricity, TV, consoles, phones, etc. That's 100% correct. Lita says we will not be able to Xbox. But let's just it all. Simpiwe says because of plastic. Buntle says they wear rubber gloves to protect themselves. We've got Lwandle that says we won't see properly at night. So that is the use of electric or street lights. Awu says no baking or lights or nowhere to store food. Buntle says I won't be able to charge my phone, so I wouldn't be able to communicate with my family and friends. Very, very good. We've got a kettle to boil water. Queen says a kettle to heat and hot water. Boiling water, that's from Michael. All right, and we've got Anonymous that says a kettle provides us with hot water. Adelaide, a kettle provides heat. All right, and so forth. Let's see what else we've got over here. Luandle says a kettle solves the problem of cold water. That's very, very good. Shakira, a kettle, it's making it easier to boil water to make tea, coffee, or other hot drinks. Queen says a lamp for lighting. All right, a speaker for sound, that's from Queen again in Jabulo, so that we can make ourselves some food. All right, so that's the answers about those pictures that I gave you. Let's see if we can find any answers regarding the owl that we saw. Just give me a sec while I scroll down, guys. Queen says a robot helps for lighting and speeding. Adelaide, traffic lights for easing the traffic. Very good. Michael says the fan gives us wind when it is hot. Caleb, robot lights and red for stop, green for go, and yellow for slow down. I'm glad that you know that. Awesome stuff. All right, still scrolling down. Sure, you guys are really, really active today. All right. Oh, and Jabula says he wants to be a lawyer. Anonymous wants to be a veterinarian. Awesome. Let's see. All right, that's about it, what I have. All right, I see Anonymous saying that, ma'am, a tree in my yard fell on the electric fence. But when my mom touched it, it didn't shock her. So it might be that the tree has been down for a while and it's not completely connected to the roots of the tree. So now if it was still a very live tree and part of the tree bark was still connected to the main of the tree, then it probably would have given her a small shock. But maybe it has been fallen down for a while and eventually died off. But if it was still connected to the mains of, the roots, then it could have still given her a shock. All right. All right, awesome, guys. Thank you for tuning in today's lesson. Thank you so much for your answers. You guys have been awesome. I see Adelaide saying that she wants to be a scientist. All right, awesome. That's very, very interesting to know. All right. All right, I think that's about all the answers that I have for you guys today and all the questions. Thank you so much for tuning in. I will see you again on Monday. Do have an awesome weekend. Remember to stay safe and stay at home. And goodbye, everybody.